Cisco course would be complete without some information on the OSI model that everybody knows and loves. Even though we don't really reference it on a daily basis, it's good for troubleshooting. It's good because it's really the flow of information that each and every process uses, whatever it does. So if you have certain problems, you can troubleshoot it almost without even looking at this model. You would probably follow the same kind of route yourself when you do troubleshooting. You would look at the different layers. You look at the physical layer, the data link layer, blah blah blah, the presentation layer, to try and figure out exactly what was wrong. So we're going to have a look at describing the purpose and basic operations of the OSI and TCP/IP models. So the OSI model, the Open System Interconnection model, is a conceptual model that characterizes and standardizes the communication functions of a telecommunication or a computer system without regard of their underlying internal structure technology. So it's application, presentation, session, transport, network, data link, and physical. Now there's many acronyms you can use to remember this, many of which I can't mention here because they're far too rude. Strange how rude things tend to stick in your mind, but I remember it as American people seem to need data processing. So American people seem to need data processing. And providing you know what A, P, S, T, N, D, A represent, you can fill these out perfectly. So the application layer, which is layer 7. This layer supports the applications and end user processes. Communication partners are identified, quality of service is identified, user authentication and privacy are considered, and any constraints on data syntax are identified as well. Everything at this layer is application specific. The layer provides application services for file transfers, email, and other network software services. Telnet and FTP applications that exist entirely in the application level, and tiered application architecture as a part of this layer as well. So within there, you'd have World Wide Web browsers, NFS, SNMP, Telnet, HTTP, and FTP. So not knowing what runs on these individual layers would be a bad thing. So even though you can remember the American people seem to need data processing, and you can write it out perfectly, unless you know what is included in every layer, then it's pretty pointless. So you need to pay attention to these things, definitely. Then you have the presentation layer. This layer provides independence from differences in data representation, such as encryption, by translating from application to network format and vice versa. The presentation layer works to transform data into the form that the application layer can accept. And this layer formats and encrypts data to be sent across the network, providing freedom from compatibility problems, and it's sometimes called a syntax layer. And within there you would have encryption, ASCII, EBCDIC, TIFF, GIF, PICT, JPEG, MPEG, MIDI, MP3, blah blah blah, that kind of thing. You get the idea. It's whatever is used to be presented. And then we have the session layer. The session layer establishes, manages, and terminates connections between applications. The session layer sets up coordinates and terminates conversations, exchanges, and dialogues between applications at each end, and it deals with session and connection coordination. Within there, you'd have things like NFS, NetBIOS names anyway, RPC, and SQL. So, transport. This layer provides transparent transfer of data between end systems or hosts, and it's responsible for end-to-end recovery and flow control. It ensures complete data transfer, and you'd SPX, TCP, and UDP. Layer 3, the network layer. It provides switching and routing technologies, creating logical paths known as virtual circuits for transmitting data from node to node. Routing and forwarding are functions of this layer, as well as addressing internetworking, error handling, congestion control, and packet sequencing. And in there, things operate such as AppleTalk, DDP, IP, IPX. Data link, the big one. At this layer, data packets are encoded and decoded into bits. It furnishes transmission protocol knowledge and management and handles errors in the physical layer. Flow control and frame synchronization also come into this as well. then the data link layer is divided into two sublayers really. You have the media access control, which is the MAC layer, and the logical link control, the LLC layer. The MAC sublayer controls how a computer on the network gains access to the data and permissions to transmit. The LLC controls frame synchronization, flow control, and error checking. And within that you would have PPP, FTDI, ATM, IEEE, HDLC, and frame relay. Then we have the good old physical layer. The physical layer conveys the bit stream, an electrical impulse, light, or radio signal through the network at electrical and the mechanical level. It provides a hardware means of sending and receiving data on a carrier, including defining cables, cards, and physical aspects as well. Fast Ethernet, RS-232, and ATM are all protocols within the physical components, as are Ethernet, FDDI, BZS, not used anymore really, V35, V24, and RJ45. So one thing I should have mentioned is that the data as it flows through these different levels is called something else every time. Now the way that we remember that is do, sergeants pay for beer. So data or packets as a pass-through application layer referred to as data. In presentation it's data. In session it's data. In transport it's segment. In network it's a packet. In the data link layer it's a frame. In the physical layer it's a byte. That's how you remember it. Do sergeants pay for beer, and as data flows through these levels, that's usually how it's referred to as it goes through the kind of encryption process, and it gets kind of bits, the different packets added onto it. If it's added on at the application layer, it's called data. If it's added on at the transport layer, it's called segment. Network, packet, data link, frame, and physical. And what about the TCP/IP model, I hear you say? So this is how it differs. The top three layers of the OSI model, the application, presentation, and session layer, are cut down into one layer for the TCP/IP model, the application layer. Transport and Transport Control Protocol and UDP are also kind of condensed into one layer, which equals transport. The networking layer of the OSI model translates to the Internet Protocol layer. Data link is the same, and physical is the same as well.